Hello everyone, I am Sakshi Lakde. Topic of our project is Telharmonium, which is a mixture of music and electricity. Telharmonium, also known as dynamophone, was an early electrical organ. Now let's see history of Telharmonium. It was developed by Thaddeus Cahill in 1896 and patented in 1897. The electrical signal from telharmonium was transmitted over wires. It was heard on the receiving end by means of horn speaker. Telharmonium is considered as first electromechanical musical instrument. It used tone wheels to generate musical sounds as electrical signals by additive synthesis. Cahill built three versions of this telharmonium. Each was a considerable advancement over the feature of its predecessor. Live performances were held in addition to telephone transmission. In these presentations, the performers sit at a console to control the instrument. The actual mechanism of the instrument itself was so large to occupy an entire room. The telharmonium foreshadowed modern electronic musical equipments in many ways. For instance, its sound output come in the form of connecting ordinary telephone receivers to large paper cones, a primitive form of loudspeakers. Cahill said that electromagnetic diaphragm were most preferable means of outputting its distinctive sound. There are no known records of its music. This image shows a person playing telharmonium. Now, Monisha will explain the construction of the telharmonium.
Hello everyone, I am Monisha Padaichi. I am going to brief about the construction of the telharmonium. Cahill's ambitious goal was to construct the perfect instrument, no less with perfect tones that were mechanically controlled with scientific precision. The telharmonium let players imitate different instruments such as organ, piano, and violin. The telharmonium was essentially a collection of 145 modified dynamos employing a number of specially geared shafts and associated indicators to produce alternating current of different audio frequencies. This signal were controlled by a multiple set of polyphonic velocity sensitive keyboards and associated banks of control. He began construction on the Mark II in 1902, which were supported by 50 engineers and craftsmen. This resulted in a colossal, never before seen monster for music creation. The components of the Mark II telharmonium were 8 metal pipes with 144 alternators with a power usage of almost 15,000 watts, and there are 10 contact panels with 2,000 switches. For musicians, there are 672 keys and 336 sliders for control. The telharmonium was 60 feet long, weighs 200 tons, and cost a price of $2 million. Now, Amanda will cover the working of telharmonium.
Working of telharmonium. Sound is made up of waves, sine waves. Sine waves stacked on top of sine waves. The way electrons move in wire and the way air molecules move in air are exactly parallel. So if you wiggle electron in way as the air molecules move, you get the same sound. So Thaddeus Cahill took a giant cog and rotated next to an electromagnetic receiver so that you can wiggle electrons in sine wave shape. If you see a cog, it has those teeth. Those teeth are sine waves. So every time a tooth would pass near the electromagnetic receiver, it would push the electrons and the gaps between the teeth. It was not a push. So you get these pushing movements resulting in sine wave which produces sounds electronically. So you have cog like this for every note on piano which produces all the frequencies we use in music. If you have cog for each note on piano, you had a whole slew of other cogs of decreasing sizes that would generate higher frequencies at lower amplitude. In this figure, the stripped lines that you see are actually the cogs used to generate frequencies. Now you must be thinking why this telharmonium is so big. Well, this device was before the invention of amplifier. So for this to be audible, it had to be huge, giant. You had to move a lot of electrons to be able to hear some sound.
Hello everyone, I'm on Gulwani, rule number 296, and I'm going to speak about advantages and disadvantages of Telharmonium and how it got managed. Advantages. Telharmonium was capable of producing any combination of notes and overtones at any dynamic level. It allows a player to combine the system of a pipe organ with the expression of a piano. Later on, Cahill produced to dispute the electronic music output of the instrument over the newly established telephone network to subscribers at home or in hotels and at public places. Let's see the major disadvantages and reasons for its downfall. The instrument was immense in size and weight, and it requires a very large space to store the instrument. It requires large electric dynamos which consume great amounts of power in order to generate sufficiently strong audio signals. Later on, problems began to arise when telephone broadcasts of telharmonium music were subject to crosstalk and unsuspecting telephone users would be interrupted by strange electronic music. By 1912, public interest had waned and Cahill Enterprise was bankrupt. That's all from us. Thank you and have a nice day.